Okay, so I'm going to describe the limit to you. My definition is as x approaches a certain value, what is y approaching? So that's the question you ask yourself when you're thinking about limits. What is y approaching? So the answer to a limit question is the y value. So I'm going to give you 4 examples. My first example is a linear function, and this is read as the limit of 2x plus 1 as x approaches 2. So I'll start by graphing it for you. So this is a linear function. The y-intercept is 1. The rate of change is 2, or the slope, so up 2 over 1, up 2 over 1, up 2 over 1. So the graph looks like this. And the question that you're being asked is the limit as x approaches 2. So here's 2 on the x-axis, and what we're doing is we're sort of looking at it like this. As x approaches 2, either from the left or from the right, what is happening to this y value? What about y value is associated with that? So if we look at it like this, what is the y value getting closer and closer to as the x value gets closer and closer? So you're actually looking here on the graph, so you're looking at it like this. And so the answer in this case is 5. 1, 2, 3, 4, 5. So as x gets closer and closer to 2, y gets closer and closer to 5. In fact, it is 5. The actual value is 5, but that's not always the case. So the answer to this question is 5. The limit as 2x plus 1 as x approaches 2 is 5. Okay, I hope that was a good explanation. Let's look at another. This is called a piecewise function because, as you can see here, the function is broken into pieces. So the function f of x is defined here as long as you don't have an x value of 2. But when you do have an x value of 2, in that case, you have y equals 3, which is a horizontal line. Or in this case, it's just a point because you're just talking about at one x value. So if you were to graph this, what you're saying is that y equals x squared plus 2, which is a quadratic. The graph is a parabola, and that's defined everywhere except at x equals 2. So let's go ahead and graph this. We know that this is a parabola and that its vertex is at 2. We could plug in a couple of quick points here. So we plug in 1 and we square it. We'll get 1 plus 2 is 3. So we have 1, 3. We also know that it's symmetric with respect to the y-axis, so that this is also a point. And of course, you could plug in -1 and you would get 3. If you plug in 2 and you square it, you get 4 plus 2 is 6. So you have 2, 6. 1, 2, 3, 4, 5, 6, 2, 6. And of course, you have -2, 6. And so, except when you read this, you actually, this function is not defined when x equals 2. So we would put an open circle here. It is defined at -2. So you have this parabola just as you normally would, like this. That should be a little more U-shaped. And you have this open circle here. And then when x is 2, we define it as just being this point 3. So 1, 2, 3. So that's what your graph looks like. It's a parabola with a hole in it, and that point is defined here. So here's an example when you talk about limit. What is the limit as f of x? What is the limit of f of x as x approaches 2? So as x is getting closer and closer to 2 from both directions, what is the y value? I can if you go up here, this is the associated y value. So as this function gets closer and closer to 2, what is the y value approaching? What is it getting closer and closer to? And the answer is 6. It doesn't matter that that point is not defined, or that that point, the x associated x value here is 3. It doesn't matter. It's what is it approaching. So if you go back to my definition, as x approaches a certain value, what is y approaching? Not what is y, but what is y approaching. So in this case, when x is 2, y is 3. But what is it approaching? It's getting closer and closer to being 6. So the limit is 6. So the limit is what are you approaching on the y-axis? Again, I hope that was a clear explanation. I have two more examples for you. This function, you might not have ever seen this, is a little bit different. Let's plug in some values and see what this function looks like. If you plug in, let's say 8, you would get 8 minus 3 is 5. The absolute value of 5 is 5. And 8 minus 3 is 5, so you get 5 over 5, which is 1. So 1, 2, 3, 4, 5, 6, 7, 8, 1. If you plug in 7, you're going to get 7 minus 3, which is 4. 7 minus 3 is 4, and 4 over 4 is 1. And that's going to keep happening. 6 minus 3 over 6 minus 3 is 1. And it's going to happen all the way until you get to 3. When you can't plug in 3 because 3 minus 3 is 0, and you can't have 0 in the denominator. So at 3, it becomes undefined. So the graph looks like this. If you were to plug in 2, 2 minus 3 is negative 1, but the absolute value is positive 1 over 2 minus 3, which is negative 1. So you have positive 1 over negative 1, which is negative 1. So when you plug in 2, you get negative 1. When you plug in 1, 1 minus 3 is negative 2, which the absolute value is 2, over 1 minus 3, which is negative 2. So now you have 2 over negative 2, which is negative 1. And this keeps happening over and over and over. So the graph looks like this. And as you approach 3, it becomes undefined at 3. So that's what the graph of the function looks like. It's kind of a different function than you're probably used to seeing. And so the question here is, what is the limit of this function as x approaches 3? So as x gets closer and closer to 3, what are you getting close to? Well, it's not the same from both directions. From here, every time you plug in an x value, your y becomes negative 1. So it's always negative 1. So you're approaching negative 1. You're getting closer and closer to this 3 being negative 1, but you're never actually going to get there. And the same thing here, as you approach from this direction, your limit is positive 1 in your y-axis. So as x gets closer and closer to positive 3, which is what I'm doing like this, the y value becomes closer and closer to being 1. But it never actually gets this. So the limit from both directions is not the same. Therefore, when you say, what is the limit? We can't answer it. So we say it does not exist. Okay, so sometimes the limit doesn't exist. And here is another example. The last example. This is a rational function, and it is not defined at x equals 4 because you can't plug 4 into this. So you learned in pre-calc that that's an asymptote, right? This should be a dotted line. It's an asymptote. And so the graph is doing something on both sides. So we can plug in some values. If we would make a quick little table here, we just need a couple of points to get an idea. If we plugged in 3, we would get 3 over negative 1, which is negative 3. So 1, 2, 3, 1, 2, 3. If we plugged in 1, we'd get 3 over negative 3, which is negative 1. And we know that the graph is going like this. And if we plugged in some points on the other side of the asymptote, let's say 5. 5 minus 4 is 1. 3 over 1 is 3. So we have 1, 2, 3, 4, 5, 1, 2, 3. And if we plugged in, let's see, 7. 7 minus 4 is 3, and 3 over 3 is 1. So 5, 6, 7, 1. And so we know that this graph is going like this. So as you approach, this is the question we're asking, as x approaches 4. So let's look at it from this side. As we go towards 4 in this direction, what's happening to the y value? It's actually going to infinity. And as we approach 4 from this direction, from the left-hand side, you're actually going to negative infinity. So limit usually is a numerical answer, as we saw earlier in the first two examples. So we would say that the limit does not exist because the y value is not approaching a single number as x is approaching 4, y is not approaching some number, so we don't have a limit, so the limit doesn't exist. That's an introduction to limits.